Hey all, uh, let's solve today's Leetcode daily, which is smallest subsequence of distinct characters. I haven't solved it before, so let's see how we can approach it and how we can solve this. I'll reset and start the stopwatch. Let's go. Given a string is lexicographical smallest subsequence of s that contain all distinct characters of s exactly once. Okay, so basically we are given a string s which contain uh, lowercase characters and length of s can be up to 1000. Now from this s we need to extract out unique characters and we need to uh, get the smallest subsequent of s that contain distinct characters only once. That is, here we have two challenges, like subsequence which contain all unique characters and their frequency of all characters should be 1. Now let me go through this example. If you take a look at BC ABC, the possible subsequences with unique characters are BCA and CAB and ABC. Now in all these subsequences we have unique characters and frequency of each character is 1. So now we need to find lexicographical smallest among all. Smallest. How do you find lexicographical smallest? If first differing character is less than next another string, then it is lexicographical smaller. Now here a is the smallest among these three things from left to right, so abc is the smallest. Similarly, if you can take here, we have a c d b. This is the lexicographical uh, smallest character which contains all the distinct characters of s, right? Hmm. Now uh, hmm, how do we approach, like, look at this. If I need current character to be in final string, what is the scenario? Now all the characters towards right must be having remaining distinct characters. First, I need a map. I need to ensure that all the characters towards right have count greater than or equals to 1. That's it. Now how do you know that? So whenever you move from left to right in a map, you will reduce the count of left variable. So once you reduce the count of left variable, now that mean uh, mm, 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 mm. yeah, that mean you have got that distinct variable into the array. Now if we got that previously, we don't need to consider it now. Got it? Now in that case, to find a lexicographical smallest subsequence, this is interesting. To get lexicographical smallest, we need to find a way so that we can do recursion, but it is n factorial. So we need to check if there is any better way. Sorry for background noise. Hmm, is there any mm, 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 mm. I'm thinking like what's the best way to take such that a final one will be lexicographical smallest. Mm, I understand this that every write should be having remaining characters letter, but we need to choose the smallest possible character. So for that, mm, hmm, can we go character wise? First, we check A. We check if all the possible are towards the right. If it is true, then we just check B. Uh, check next. So like we go to first main character in map and check if possible. If yes, do same for next minimum. Yeah, we go A. We check if all the remaining characters are towards right. Yeah, it is possible. Now, yeah, we can do this greedy approach. What would be complexity? We are traversing all the characters of like 26, suppose 26 star 26 remaining of n is like a length of the map, all the distinct characters we have. Yeah, let's write the code. First, uh, how do we store the elements? We need to get need to remove the next leftmost, so we need to do pop from the left and mm, we can store the index in a counter array and check if it is visited or not. If it is visited, how to know that if it is already in the answer. If it is not, we need to remove the largest before that, so that the larger one will come towards right of it. Okay, I think we can use stack for it. Stack, yeah. Let me go through the first. We need a count to store the last index for each character. 26 for int I equals to 0, I less than 26, I plus plus, sorry, I less than s dot size not 26. Yeah. Now last of s of I minus a plus plus. Yeah, we are good here. We got the count. Next thing what we need to focus on is for every string, yes, for int I equals to 0, I less than s dot size I plus plus, we need to check let char ch equals to s of I. If it is already visited, so let me take a visited array. Visited of 26 comma false. Do we need visited? Yeah, we change it. Okay, so let us keep it. Now if visited of minus a, we don't need to do any operation, we just continue. If not visited, now we need to remove the longest, which are in not stack dot empty. We needed stack, but int is enough, right, for here. Char stack, yeah. Well, not stack dot empty, and why do we even need a stack? We can just take a string so that we can return fast, right? Stack dot back is greater than current character, and last is already greater back minus a is already greater than a. It is towards right, so that we can pop last of stack dot back minus we don't need to change anything there, we just need to modify the visited, sorry, stack dot back not character, yeah, equals to true. Oh, not, it is false. Stack dot pop underscore back, we need to false it and pop back, right? Yeah. Now we need to push our current character to stack string. Yeah. Now, yeah, again we need to change the visited of current character to false. That's important. Because this is the minimum most which we can add it. Sorry, why false? I messed up today. Yeah. We have last index. If we have character which has last index greater than correct index and which can come later, we just pop back and We just add current character to string and we just return string. Yeah. Let me run and submit. Let's go. Oh, what is the issue here? If it is visited, we just send if track dot not empty and it is greater than correct character and its index is greater than I, we make it false and we just pop back and we push back current character and we let it as true. Then why B came into picture? Same issue with the second thing, right? ACDB should be at last. BCA. Oh, I'm incrementing count here instead of assigning index. Sorry. Huh. Yeah. Now let me submit this. Yeah, we are good. So the key thing is like being greedy. We need to get the minimum current character so that all the maximum can be come towards right. If there is only no maximum character towards right, we don't have any choice, we must need it. So in this way we perform the operation. And time we are doing only once, so it is O of n space 26 size for storing last index and visited array, and O of n for string st. That's it. Bye.